how we can use the smart technology to improve infrastructure resilience. This is the topic. Why today we are speaking about infrastructure resilience, where we're speaking about smart technology. To answer this question, first of all, if we look to some international data about the climate change impact, you can see in this figure here, we have the number of disasters from 1950 to 2012. In this color, we have the disasters which are related to the climate. And it's very evident that we have very important increase in the number and also in the magnitude of these disasters. In the red color, we have the economic impact, and we can see globally also we have very important impact. Then there is now an agreement that the climate change is already here and it has very high impact. Now, question that what is the consequences on our infrastructure? We know that in civil engineering, when we design our infrastructure, they are designed to a level of hazard. For the amplitude and the frequency, we record over all of these events, and we try to design our structure according to this hazard. It depends on the site and so on. Now, if we look to the impact of the climate change, it's evident that we have an increase in the hazard level. And the question that with this increase, all of the design of some of our infrastructure are, some of these infrastructure were not designed to meet this level of hazard. Question that what we can do, what could we do in this case? We have two solutions. First one, okay, we know we have some ideas about the level and we can upgrade our infrastructure. But you imagine that it's a huge work because we have a lot of infrastructure. It requires a huge investment and take a lot of time. And for some of our infrastructure, we cannot wait and we don't have the investment. The second possibility to see, could we high perform and adapt our infrastructure to the new challenges? And for this, we want to combine three things. First of all, if we look to our infrastructure, we want to consider them as a socio-technical system. They are not only technical system. I will come back to this one to see with the resilience approach, how it could be helpful. And this one, see that this combination of the resilient with the smart technology could be really very interesting. With this, we can have this concept of what we call the smart and resilient infrastructure. That's what I want to present. First of all, if we look to our system, mainly in urban area, because you know the disaster or hazard has very important impact in urban area. We have our what we call the built environment, but we have also the communities, the administration, public services, the private sector, the activity, and under the hazard, all of these components are concerned. And to fight the hazards also, all of these components could participate, could contribute. And all of these components are also in interaction, are dependent. Then, if we want really to have a very good strategy, we have to have the consideration of all of our system. It's not only the technical system, but also all of these aspects. That's the first thing. Second thing, if we look to the hazard management of this system, I take any system, it could be the levee, or it could be a bridge or a tunnel and so on. No, in the design, it's designed for what we call the original level of performance to this level. Now, if I have a hazard, it starts from here, it could be earthquake or a flood. The impact is we have some delay generally, you know, for the impact. This delay is very important. It could be very short. For the earthquake, it could be some seconds, but these seconds could be really very interesting. In flood, it could be some hours and so on. Then this phase, what we call the early phase. After we'll see the impact of the hazard with a decrease in the performances down to a given level. And after we have the recovery phase with the emergency and so on, we can recover, and the objective is to see if we can come back to we call the original level. That's what we do in our system. Then we have three phases. And the objective in our system is to see, could we design our system, the preparation phase, to reduce the damage? And also, could we organize our system in order to reduce also the covering time? This is the most important thing for us. Now, if we look to what we call the resilience approach, in this approach, it's mainly related to what we call the learning. We want to learn. And we want to learn, we need to get data and information. The resilience is based on this. Then the question that, what is our capacity today to collect the data for our system from the phase of preparation of our system during the early phase, this phase, and this phase? Then the question that, what is our capacity? Because if we want to improve, we need to have this data. Once we have this data, we will use, and we'll come back to this one, some advanced methods such as artificial intelligence, big data, and so on. Then we will learn, we will improve our capacity, and we'll see that we have also some advanced technology for the control of our system. Then we will come back here to improve all of these phases. And the objective now is to reduce this one and to see, since we know now more about our infrastructure system, could we arrive to a system with higher performances than before? This is the philosophy of the resilience approach. Now, if we want to implement it, you can see that we need what we call comprehensive monitoring or data collection. We need high capacity of data analysis. We need also high capacity of control, and we also need to involve our community. That's what we would like to do, and we see that the smart city could be really very helpful in some of these phases. Now, if we look to the third part, we speak about smart technology. This concept has been developing now for about 15 years with different concepts. We speak about the smart city, smart building, smart grid, and so on. Then we have a lot of things about this. If we look to the smart city, now if we look around the world, the biggest cities today have their own project smart city. All over the world, we have these projects, and we have very important projects. In Europe, we have more than 500 projects. In China, we have more than 200. In India, we have 100 projects. We have also in Africa. Everywhere, this concept is developing very, very quickly about the use of this technology. Now, what is this technology? What is important in this technology that it's inspired from the human intelligence? You know, the human intelligence, we have three components. The first one is sensing. It's a question of interaction with our environment to capture the data. Cognitive, to see how we can analyze the data to take some decision, and after our capacity to make action according to this analysis. And the quality of all of these phases is related to the experience, how we can learn from our events and improve our capacity in each of them and in the global. Now, if I take this concept and I want to go to the city to see how we can apply it, take any urban system. It could be the city, it could be Lille, any system, urban system. If I want to apply this concept of intelligence, first of all, this system, I need a digital model to see how I can describe my urban system in my computer. You can use something such as BEAM, you can use GIS, and so on. Then I will have the picture with the details, special description, but also description of all the components. We can make also the process, and so we can put a lot of information in this one. Now we want to communicate with our urban system, and then we will add what we call the sensing layer. We'll put our sensors, but not only our sensors, we'll see that we have other things we can put to get the real-time data, and we'll store all of this data in our information system. Then we will have both historical and real-time data. Once we have this data, we will use our analysis capacity. We have different tools for this, And the question that how we can transform our data into services, what we call smart services. And for the application of these smart services, we need what we call the control layer for our system. This is how our system works. Then with the events, we will improve our information system, this analysis, and our system will be self-learning, and it will improve its performances. We can present in another way as what we call the layers. Here we have our physical layer, the monitoring layer, the data transmission layer, the layer about data processing and analysis, the service layer, which will be applied in our social system. I will focus on two of these layers, which are really very, very important for the smart city. Let's look to the layer of data, because the quality of the smart city projects is related to the quality of data. If we look to this one, what data could we put? First of all, as I said, that we want to have an idea or a good modeling of urban system. Then we can use different technology. We need the operating data, then we can also use different technology. We need data from people. That's what we call crowdsourcing, things, social media, citizen contribution. We have today also a lot of open data. We can get this data. And we have also some data from some companies, from public authorities, and they can authorize us to collect all of this data. And we can collect all of this data, and we'll have all of this data in only one system. That's what we call comprehensive data. And this data, as you can see, that they will cover the different area in the city. They will cover our infrastructure, building, the services, the users, people, but we have to be care about the privacy of the users. And also we can have the data for the environment. That's about the data. Then today we have this capacity to collect a large amount of data. To collect this data, we have the digital tools, such as the internet, the social media, the mobile, the Internet of Things. The Internet of Things is really very important. We have more than 20 billion Internet of Things. This machine where we can capture the information, make local analysis, and make some decision in the local. They are interested because we know where they are. They could be easily connected. They can make some analysis, and they can also make some action. Then what is important in our world today, that we live in what we call connected world. People are connected, things are connected, people and things are connected at very large scale. The mobile, we see it almost everywhere today. What is interesting in the mobile, that in the mobile we can also have a lot of sensors. In some mobile, we have up to 19 sensors. And these sensors are really very interesting, and they are helpful for the smart city. These mobile today are used also in disaster management. A lot of application for flood management, tsunami, earthquake, and so on, where some NGOs, some countries developed some application, and people can send very quickly this information to authorities. This one is really very interesting, and now it's already used in some areas. And this also is a very important research area. You can see that we have a lot of papers today in this area about how we can use the smartphone for the smart city. This one, look at the video surveillance. It's mainly used for security. We have about 800 million cameras around the world, and we will reach about 1 billion. These cameras or these videos will send us real-time information, and today we have this capacity with the AI to analyze this data. Then if we can work with the security services for in hazard period, we can also get very important information, and this information could be helpful. The drone is today very used. It's very interesting. The robotics are also very interesting. We can use them in difficult access area at large scale and so on. This is a real revolution today also in hazard management. The crowdsourcing, it's how we can collect the data. And all this data about the social media, we can have access to this data. And today we have a lot of tools which can transform these data into what we call the semantic analysis, into information, and interesting information, because this information is about emotion. And emotion is very important to understand what's going on in the city. And it's something which is also interesting. And we can see today we have powerful tool in order to see how we can use the social media in smart cities. It's also used in disaster management, which is interesting. We can have passive information or active information. We can have information about public sentiment. We can also improve the response. And this one is already used also in some areas. Now, concerning the data processing, for the data processing, you see that we have also different tools. We have the professional tools. We have statistical tools, but what is important is this one, this big data. Big data, we have specific tools today which can deal with a huge amount of data with very important data flow, because we need a response in real time. The artificial intelligence today is very interesting. These tools are also very interesting. And also we can see that we have also some papers, some very recent papers about how we can use these tools and also in disaster management. Now, with this, we can, when we combine data analysis, we can offer some services, we can improve the security and the safety, we can make what we call optimal management, we can improve the asset management and so on. Then we can, you can see that here we have different services which we can offer for the communities. Now, to give you only very short illustration of what could be this technology, we have been working at the University of Lille on what we call a pilot project at the campus. This pilot project, you can see our campus, the city, look like a small town. And what was interesting that we have all of these urban network. And all of these urban networks belong to the university. Then it was very easy to go to put our sensors to get the data and analyze the data. When we started this project, we had a very important partnership. You can see with the local government, with the international partners, with research laboratory, education, and so on. Also with the private sector. We have about more than 20 very important partners, national partners, and so on. And for this project, we had a European project for the water. The European Commission gave us about €1 million for the implementation of our sensors, of our monitoring system. And also we have included a lot of students, as you can see here, in the PhD program, the master's degree program. I will give you only what we did in the water area. This is the water network of the campus. You can see it's very old and very bad situation. We have a lot of problems with this water network. Then we applied this technology. We put our monitoring system mainly for leak. We put these sensors to measure the water flow, but also we are interested by the water quality. Then we also put some sensors to have real-time information about the water quality. And after we put information data collection and so on. If I look to one of these results, look to the water leak. Here we have the water losses every day. Before we start really the project, you can see that we had very important water leak. It was about 500 cubic meter a day. It's more than €2,000 a day. It's very important. When we started our project, the project was operational. You can see that the leak dropped in a very important way. And sometimes when we have a leak, it was prepared in the same day. And you can see this event. Then you can see that this technology is really effective. We go from this situation to this situation. And in only 1 year, we made a saving of about €120,000. And our investment in the monitoring was only €40,000. Then this example is really very interesting. You have another example here about the water quality. The natural situation, normal situation is here, and sometimes when we have some peaks here, it means that we have also some problem with the water quality. We analyze these data, and the analysis could be used in some tools for the management of our system. Now, I want to go to that last part about how we can combine the smart and the resilience. The question that want to combine this approach, which I presented here, with this approach. This is what we want to do. For the data, which is interesting for this approach, that we have already a lot of data if we have the smart city. All of these data are relevant to the smart city. Now, if we want to go to the infrastructure resilience, we need specific data, such as the natural hazard, the disaster preparation, the early warning. This one is really very important. I will come back to it. Then, if we want to go to this, the question that we want to combine this one and this one. This one is already available in the smart city, and I want only to build this one. This is why this concept is really interesting. For the early warning system, this time, very short time where we can detect that we have an event. We have today a lot of development, for the early warning system for the earthquake in Japan, United States, and Italy. And we can detect, before the earthquake occurs in land, something, and then we have some time to shut down some critical infrastructure to make some awareness for people and so on. And in this area also, there was some development about the use of the mobile. In the mobile, people can send very quickly the information, we can capture the information, and it also could be used as early warning system. The same thing for flood also, we have also a lot of tools which we are prepared also with the monitoring system for the early warning system. Now, for the analysis, it's the same as I said in the smart city, but we will have more focus on these two tools because when we have the disaster, we don't have a lot of time. We should make the analysis and take decision in real time. And these two tools are really very interesting to be used in this system. Now, if I look to this phase, what we call the early phase. The early phase is one of the most important phases in the disaster. We can see that we can combine this system, what we call the early warning system. But what is interesting is this one, because we have the possibility to take rapid action, to see for some critical infrastructure, if we have some automation, to inform the governing body, for the emergency services, the communities. If we combine both of them with all of the information which we have, we can really improve the management of this phase. If we look to the second phase, this one, we have much more tools because we need to have a scan, first of all, of the damages. We can involve the community. We can improve the emergency because we have the real-time information. We can have the real needs, the resources, and so on. We can increase, which is really very important, the capacity in what we call the degraded mode, because during a disaster, we can lose some capacity. But the question that how we can continue to work. And this one is really very interesting. The smart city is very efficient in this way. The healing also in some complex systems, such as the electrical system, it's not easy to put back the system. Then we need also some technology, and also we can make evaluation of the performance and evaluation. That's about this technology, why this technology is really very interesting. What we can do finally, what we can conclude, I think that this concept is really interesting. With this increase in the hazard, I think that it could be very valuable, way or approach to hazard management. The problem that we don't, up to now, we have enough experience in this area. It's a new area. And when we have a new area in engineering, we would like to have what we call the pilot project. With this pilot project, we can explore, we can learn, and so on. This one is really very important to have a pilot project in this area. I think that the Living Lab, to conclude, could be really an excellent candidate for this pilot project. Thank you for listening. It's been my pleasure to answer if you have some questions.